The topic is reduction of order. So let's do this example. Given that y1 of x equal e to the x over 3 is a solution of 6 second derivative of y plus first derivative of y minus y equals 0, use reduction of order to find a second solution y2. Of course, we're seeking a second solution such that we want y1 and y2 to be independent. So since y1 and y2 is independent, so y2 or y1 y2 cannot be written as a number times y1. What this means is y2 over y1 cannot be a constant. So therefore, we usually assume the second function that we're looking for is going to be not a constant times y1, so it's going to be some function of x, u of x. We just write to u times y1. In other words, we want our y to be equally u times y1 is given, it's right here, times e x over 3. So this is the function we're looking for. Alright, so what does that mean? Y is equal to u e to the x over 3. So what we do, we need to find the first derivative, second derivative, and just plug them into the equation and then try to solve for u. Alright, so what do? Since y is equal to ue to the x over 3, then y prime is going to be the derivative, which is using the product rule, will be u prime e x over 3 plus derivative of e to the x over 3 is 1 over 3 e x over 3 times the u. Right? Now what about second derivative? Second derivative will be derivative of that, again, product rule, so second derivative of u e x over 3 plus derivative e to the x over 3 is 1 over 3 x e x over 3 times u prime. This is just, all of this stuff is just the derivative of this part. We still need to do the derivative of this. Now, derivative of 1 over 3 x over 3. 1 over 3 times 1 over 3 is 1 over 9. So 1 over 9 e x over 3 times the u plus derivative of u, which is u prime, times 1 over 3 e x over 3. Now let's rewrite this nicely. So second derivative of y is going to be equal u, second derivative of u e x over 3 plus, just going to add all those terms that has y prime. So this term plus this term, 1 over 3 plus 1 over 3 is 2 over 3. So 2 over 3 e x over 3 times u prime plus, this is the only term that has a u, plus 1 over 9 e x over 3 u. Alright, now let's plug everything into the equation. So 6, let me rewrite it, 6 y double prime plus y prime minus y is equal to 0 means what? This means that 6 times u double prime ex over 3 plus 2 over 3 ex over 3 u prime plus 1 over 9 EX over 3 U. So this is just 6 times double Y double prime. Now plus Y prime is U prime EX over 3 plus 1 over 3 EX over 3 U minus U EX, that's a Y, minus Y, which is 0. Now let's distribute. If we distribute, we'll get 6E X over 3 U double prime plus 6 times 2, 12 divided by 3 is 4, so it's 4E X over 3 U prime plus 6 times 1, 6 divided by 9, 6 over 9, which is 2 over 3, 2 over 3 E X over 3 U plus, those just add them up, so EX over 3 U prime plus 1 over 3 EX over 3 U minus EX over 3 U, and this is going to be 0. Alright, what's next? Alright, anything that has U double prime, nothing, so let me write this down. So 6E X over 3 U double prime. What about things that has a U prime? So this is 4 plus 1. So 4 plus 1 will be 5. So 5E X over 3 U prime. So this is gone, this is gone, and this is gone. Now what about all those that has E3? So 2/3. This one is 2/3 plus 1/3. Right, 2/3 plus 1/3 minus 1 is equal what? 3 over 3 is 1, minus 1 is 0, so they're going to just cancel. So this is going to be equal to 0. Now we can divide by e to the x over 3. This will go, so you'll have 6u double prime plus 5u prime is 0. Well, now to use integrating factor method, we need to write this in a standard form. Standard form will be, we need to get rid of the 6 divided by 6. You get u double prime plus 5 over 6 u prime is equal 0. And to make it easy, we'll let v equal u prime, which means v prime plus 5 over 6 v is 0. This equation is pretty easy. You can use integrating factor. Now I is equal e integral 5 over 6, right here in dx, which is e 5 over 6x. Alright, what's next? Now what do we need to do? Multiply e to the 5, multiply the integrating factor by both sides of this equation. So you'll get e 5 over 6x v prime plus 5 over 6 e 5 over 6x v, which is 0. Now we know that this is just the integrating factor times v, everything prime, which is 0. This tells us that e 5 6x v is equal to some constant. I'm just going to call it c1 because always c2 appear, you can even tell. Now this means that v is equal c1 times e negative 5 over 6x. All I'm doing dividing by e to the 5 over 6x. Now remember, don't forget, v is just, this is just a u prime. It's right here. Where did we suppose that? Yeah, see? So what this says, u prime is equal C1e negative 5 over 6x. Okay, let's move on to the next page. Now the u has to be the integral, right? To get a u from u prime, we integrate. So this is the integral of c1. I'm just going to take c1 outside. Integral of c1e negative 5 over 6x dx. It's an easy integral. It's going to be 1 over negative 5 over 6e negative 5 over 6x plus some other function. Now the u is equal negative 6 over 5 c1 e negative 5 over 6x plus c2. But don't forget the u, we're looking for the y, but y is equal u times e x over 3. This means that y is equal, so we multiply, this is the u multiplied by e to the x over 3 Now all we need to do is distribute. This will be equal to negative 6 over 5 c1. Now remember, multiplying those e's means adding the exponents. Let me do it here. If you add x over 3 plus minus 5 over 6x, let's just add in fractions. This is going to be equal to negative 1 over 2x. So this is going to be e negative x over 2 plus distribute, you get c2ex over 3. Now we're seeking a solution, any solution that's independent. So since y1 comes from, y1 is e, this is y1 if we let c2. So we want the c2 to be 0 to get an independent one. And we want c1 to be any number, but the easiest, the nicest number will be c1 equal negative 5 over 6. So this will give us y2 equal e to the negative x over 2. And that's our solution. That's the second solution. And that's it for this example.